Hi, my name is Dean Hildebrand, and I'm here to talk about building an online archive with OpenStack Swift. So Elastic Storage combines OpenStack Swift with that of a scale-out parallel file system that can tier data across a variety of different sources, as well as across data centers. And in addition, it can store and tier data down to tape. So why tape? Isn't this world, isn't it about software defined and trying to store as much as you can in the software level? Well, the truth is that in order to really provide another level, another order of magnitude of cost savings on the objects that you want to store, tape becomes a really viable option in many use cases. One of those being with archive data, where in many cases the write workload far dominates the read workload, in many cases being at 95 to 5 percentage points in terms of the write to read ratios. In addition, in many workloads, data is very hot at the beginning, but then over time the access fades, in which case this type of data can then be safely tiered down to tape and with minimal disruption to running workloads. Examples of that are, let's say, projects that you work on, and once the project is completed, the data can be tiered down to tape without anyone even noting the difference, as well as, for example, scientific weather data that is initially analyzed, but then over time becomes less useful. So stepping back for a second, what is Elastic Storage Object? So this is combining OpenStack Swift with IBM's Elastic Storage. It can provide file and object access to the same set of data through the Swift on File Stackforge project, as well as provide a variety of enterprise features such as snapshots, backup, mature erasure coding, as well as items like encryption and even a disk hospital that can monitor faulty disks and take proactive action before they become a problem in the system. So with Elastic Storage, data can be initially written to the topmost tier, which could be SSDs or SAS disks, and then over time tiered through user-based policies down to the lower levels. So you can start at one tier and move down to another tier, and then eventually bring down to the lowest tier, which could be an external pool such as a tape device. And then upon access, data is automatically re-tiered into the system onto disk and immediately returned to the clients. So looking at this system with OpenStack Swift, policies can be created by users to determine how they want to move objects between the running disks in the top tiers down to the lower tiers of tape. Example policies might be to move entire containers between tape and disk, or, for example, instituting the cold and hot file policies where hot files are automatically up-tiered to the highest level and cold objects are automatically tiered down to the lowest level. This integration with external storage pools is done through the DMAPI interface, which is the data management API, and can support a variety of external storage pools such as TSM, the Tivoli Storage Manager, as well as LTFS and deduplication devices such as ProtectTier. One important aspect with tape, and which is especially important with OpenStack Swift, is to avoid unnecessary recalls of data from tape and up to disks and back again, and to avoid thrashing. So some of the things in the system to avoid that are to ensure that all object attributes, including extended attributes, which store many aspects of Swift, such as the hash of the file to ensure correctness, are all stored continuously on disk and never down-tiered to tape to ensure that it doesn't impede the day-to-day operations of the system. In addition, information, the container and account information in OpenStack Swift is continued to store on tape as well, on disk as well, and never down-tiered to tape unless that's what the user wants. But this ensures that listings of accounts or containers or creation of various metadata within the system can be continuously fast and not delayed by any tape access. And finally, another important aspect of the system is that when data is accessed, the cold data is accessed and it needs to be up-tiered. This can, take a little bit of time, and so it's important that we've increased the timeouts within the Swift system itself, as well as the clients that access it may need to realize that data might take a little bit longer to access on first access. But then once it's been tiered into the disk system, access is as fast as it always was. So to demonstrate the flexibility of the system, we've created two systems, two prototypes and systems to demonstrate it. The first is to create an active archive with LTFS. And in this system, we've combined a disk pool, a single disk pool, with the LTFS system on the back. This can reduce cost up to 6 times compared to just using disk itself, and can store tens of petabytes of data. And our second example is building an active archive with a protect tier deduplication device. In this system, data is transferred between the primary system, which is elastic storage, and down to the protect tier device using the NFS protocol. A single deduplicated copy of the data is then stored on the protect tier device and up-tiered as the data is accessed. This provides an extremely low TCO of your data, and depending on your data set, can reduce your storage footprint by up to 25-1. While providing continuously fast access to your data, which can down and up tier data at up to 700 megabytes per second and store 25 petabytes of data within a single deduplication pool. So in summary, the goal of bringing tape into the OpenStack Swift environment is to drive down storage costs, which it reduces the total TCO of both 3x replication as well as even erasure-coded data, as well as keeping the important aspects of keeping the high tier available for the most commonly accessed data and moving all of the cold data down to the cheaper tiers. We can build compliant archives as well to ensure the usefulness. The system is easy to manage, and as I stated, has policy-based tiering and can scale out to the needs of the applications. So in summary, this aspect of combining tape with Swift is just one aspect of the larger elastic storage support, which has a variety of file access protocols, Hadoop support, as well as support for all the other OpenStack storage environments, including Glance, Cinder, Manila, and Nova. Thank you very much.